Okay, we class start ചെയ്യാം. Linearity of Fourier transform. The Fourier transform is a linear operation. That is, for any functions f of x and g of x whose Fourier transform exists at any constants a and b, the Fourier transform of a g plus bg, f plus bg exists, and it is f of f plus bg is equal to a into f of f plus b into f of g. It's very simple to understand. Just substitute. I think we have discussed it already. We have discussed f of f plus bg of x equal to 1 by root 2 pi integral minus infinity to infinity f of x plus bg of x e raised to minus w of x dx, and it can be simplified like this. Take the constants outside, and it is a into f of x plus b into f of g of x. So let f of x be the continuous on the x-axis, and f of x tends to 0 as mod x tends to infinity, and let f dash of x be absolutely integrable on the x-axis. Then f of f dash of x, that means Fourier transform of derivative is equal to I w into f of x. It is also very simple. We can see that f of f dash of x equal to 1 by root 2 pi integral minus infinity to infinity f dash of x e raised to minus I w of x dx. So we can integrate by the method of integration by parts, so that the first function is e raised to I w x, second function is treated as f dash of x. So integral of this one, it will be 1 by root 2 p is taken outside, and then the first function e raised to minus I w x into integral of second, that is f of x, from minus infinity to infinity minus integral derivative of the first function. What is that? Minus I w into e raised to minus I w x, that is, so minus I w is taken outside, then integral of second function, that is integral of f dash, that is f. So substituted here, and you can see that the given conditions are f of x tends to 0 as mod x tends to 0 infinity. So the first term will become 0, and the remaining term is I w into f of x. So this can be iteratively we can find out the Fourier transform of double dash if they exist in this way. So let us consider this example. We have discussed the theory part in the last class, and we can consider this example: f of x into minus x to x square. So what is that? E raised to minus x square has the derivative e raised to minus x square into minus 2x. Okay, so that derivative is and along with minus 1 by 2, so the derivative of this will be minus 1 by 2 into minus 2x into e raised to minus x square. That is nothing but x into e raised to minus x square. Okay, so instead of this one, we can consider this x into e raised to minus x square as derivative of this function. Okay, so this is, so what is f? F is minus 1 by 2 into e raised to minus x square. So the derivative of that function is x into e raised to minus x square. So we have to find out the Fourier transform of that derivative. So then that minus, by linearity property, that minus 1 by 2 can be taken outside, so that will be minus 1 by 2 into f of e raised to minus x square prime, first derivative dash. Okay, then look at this formula: f of f dash of x equal to I w into f of x. We can apply that formula. So it will be minus 1 by 2 I w into f of e raised to minus x square. Okay, so that equal to minus 1 by 2 into I w into, so what is that Fourier transform of e raised to minus x square? That is 1 by root 2 into e raised to minus w square by 4. I think we have to refer table 3, that is formula already I is available in table 3. Table 1 is this. Have you tried for these examples? I told you to try for getting the answer for these examples. I don't know whether you have tried or not. And in table 3 you can see that, yeah, e raised to minus then e raised to minus ax square has the transform 1 by root 2 a into e raised to minus w square by 4a. Okay, so you have to use that result. Using that result we can see that yeah, this we can substitute that. Instead of a we can use what is that, 1 by 4. 1 by 4. So you can you will get an answer like this. Then by 2a. Raised to minus a w square. So instead of a we have to consider it as 1 by 4. So when we replace it, what in that? So a is 1. So if you put a equal to 1, we will get 1 by root 2 into e raised to minus w square by 4. Okay. So that is the result. Okay, so that equal to, we can rearrange it, minus iw by 2 root 2 e raised to minus w square by 4. Right? So that is the application of the Laplace transformation of the derivative. Okay, you can do many problems from the exercise. Now we move to the convolution. The convolution of f of functions f and g is defined by f star g, that is nothing but h of x equal to f star g of x, that equal to integral minus infinity to infinity f of p into g of x minus p dp, that equal to integral minus infinity to infinity f of x minus p g of p dp. Okay, so this is the usual formula for convolution, and moreover you know that yeah, let us consider this theorem. This is a convolution. Convolution, actually convolution is the distribution of the sum. Okay, convolution in the probability theory you will see that the convolution results in probability theory, the convolution results are used for computation of sum, difference, quotient, product, etc. I will show you. That is available in the book of Rahaji. So that is the application. Okay, I will share you that book with you later. Suppose that f of x and g of x are piecewise continuous, bounded and absolutely integrable on the x-axis. Then f of f star g is equal to root 2 pi into f of f into f of g. So let us consider this convolution, Laplace transform convolution. So Laplace transform convolution is f of f star g, that equal to 1 by root 2 pi into integral minus infinity to infinity f star g e raised to iwx. So instead of f star g, we can write it as integral minus infinity to infinity integral minus infinity f of p into g of x minus p dp. So we have substituted that convolution formula here in the Laplace transformation, Fourier transformation formula, e raised to iwx dx. So you can interchange the order of integration because the functions are considered to be exist, and moreover f of x tends to 0, what f of x is 0, we have assumed that. So f of f star g is equal to 1 by root 2 pi integral minus infinity to infinity, again integral minus infinity to infinity f of p g of x minus p. Just interchange the order of integration, e raised to iwx dx dp, right? So now let us consider x minus p is equal to q, then x equal to p by q. So f of f star g is equal to, we can consider it as 1 by root 2 pi, rewrite it as minus integral minus infinity to infinity, again integral minus infinity to infinity f of p g of q, because x minus p is q, g of q raised to minus iw p plus q dq dp. So this can be considered as product of two integral, because p and q can be we can consider two functions, f of p into e raised to iwp and g of q into e raised to iwq. So since it is the product, so we can separate like this, and we can put the integration also like this, and we can see that. So first term is another if 1 by root 2 pi is here, and this integral is nothing but if 1 by root 2 pi is with this integral, that will be Fourier transformation of f. So since 1 by root 2 pi is not there, we can write like this, root 2 pi into f of f, Fourier transformation of f. And similarly for the second integral, it can be write like this, root 2 pi into f of g. Okay. So that equal to root 2 pi can be get cancelled. This is not minus, it is equal. 1 root 2 pi will be remaining there. Then root 2 pi into f of f into g of g. So that is the formula. Laplace Fourier transform of f star g is equal to root 2 pi into Fourier transform of f into Fourier transform of g. Okay. Okay. So what will be the inverse? What will be the inverse? What about the inverse? Okay. By taking the inverse of transform from both sides, we can write f cap is equal to f of f, and g cap is equal to f of g, and then root 2 pi and minus 1 by root 2 pi in equation 12 and 7 cancel each other. So we have you know that the transformation equation 12 and 7, we can refer that equation 12, this 12. Okay, what is 7? That is the inverse equation of inverse transformation. Okay, so there will be one root 2 pi there. Yeah, this is root 2 pi into 1 by root 2 pi into integral minus infinity to infinity f cap of e raised to iwx. Okay, so 1 by root 2 pi into integral minus infinity to, what is f, instead of f cap we can consider it as f star g. f star g, f star g. So uh, we can consider the transformation here. So that is f star g. F star g is there, and Laplace transformation of the f of f star g is, we have already computed, that is 2 pi into 2 pi into what is that? Yeah, 2 pi into f of f into f of g. Okay, so what will be the inverse? Inverse will be this one. What is that? F star g. So along with one there is a root 2 pi is there, root 2 pi with the equation f of f star g, and inverse of f cap of w and g cap of w. F cap of and g cap of w means, so that is actually represented like this. Yeah, f of so we should have, what is that? F star g is there, f of f star g is there. And this equation 10. No, that is not 10, it should be 12. Yeah, this is 12. F of f star g, that is 12. Here we have, yeah, 1 by root 2 pi is missing here. 1 by root 2 pi is missing here. Then only we can say that this is f cap of what is that? F cap of, I will show that formula here. F cap of w, using the Fourier transformation formula. Yeah, this one. F of x equal to 1 by root 2 pi into f cap of w. What is f cap? This one. F cap of w is equal to 1 by root 2 pi into integral minus infinity to infinity f of x into e raised to minus iwx. So 1 by root 2 pi is missing there. So we have to put that 1 by root 2 pi, so that we have to multiply root 2 pi and 1 by root 2 pi. Then we will get, where is that? Yeah, here we can multiply 1 by root 2 pi, and so this will be f cap of, what is this? F cap of w, and this is g cap of w. If we have 1 by root 2 pi here, so we apply root 2 pi multiply and divide root 2 pi, then we will get root 2 pi into f cap of w, right, into g cap of w. Okay, so what will be the inverse? F cap of w into g cap of w. So what is the inverse formula there? You know the inverse formula, you can see that. Yeah, this is the inverse formula. What is the inverse formula? So instead of f cap, we can write f cap of w into g cap of w, f cap of w into g cap of w. Okay, so and 1 root 2 pi will be there, that will be get cancelled, and you will have the inverse. What is the inverse? F cap of W into F star of G. F star of G. What is that? F star of G of X equal to this one, F cap of W into G cap of W e raised to IWX dW. Okay, using that equation. Since we have already one root 2 pi outside, that root 2 pi will get cancelled with the, what is that, what you have seen here. Okay. Yeah, here we have 1 by root 2 pi, and we have already multiplied root 2 pi, so that root 2 pi and this root 2 pi will get cancelled, and we will get F star of G is equal to integral minus infinity to infinity. What is that? Instead of F cap, we have F cap of W and G cap of W. Okay, so that is the technique for getting the inverse Fourier transformation. Okay. No, so you no need to consider this section, no problem. Anyway, let us skip that section. Okay, anyway, let us stop here, and we will have examination in the next Friday, coming Friday, and after that we can do some problems, available problems, and you may try the exercise also, because we have only one more week, and during that week we have to complete all our portions in our syllabus, so we have a little time. So you may yourself try the exercise problems, and you can get trained with the problems. Okay, you should study this table of transformations. It will be helpful for doing problems. Okay.